All right, moving along, we have Lech Musynski.
Hi, everyone. I hope you managed to scan the QR code that Erika was putting on. This is a really great series. I've watched almost all seminars on both of them, and I highly recommend it. Just watching back and watching the next iteration that is going to come soon. Okay, so a quick summary, I'll try, on the research on TDI money or on money that has been leveraged by TDI or research that was inspired by by things that started with TDI. Let's take a look at it. First thing would be the global mass timber panel industry in the new normal. I mean, this is like a project with long history. You can see that it's been funded by TDI back in 2020. It was like right before the pandemic happened. We've already, by that time, we had a lot of data collected. So it was tempting to us to see how the pandemic is going to affect the industry. And we conducted a survey and the interviews and sites visits with interviews to find out what would happen. Now, generally, the way of collecting data is in our belief that one of the best services that we can do to our local North American mass timber panel industry is to look elsewhere, not only in Europe, in the Central Europe, where all of these things started, but also in other developing markets and see how they cope with challenges that they face. And this is an important context to everything that has been discussed here before, because this is the industry that produces all of these panels and buildings, essentially develops, collaborates with you, develops new exciting stuff and projects. So what we do is collecting all kind of data from starting from the industry gossip columns, trade journals, surveys, site visits, as I said, and we generate lots of data. And I'm going to go through. No, I'm not going to go through all of this in here. This would take more than 3 times what I'm allowed here. It's been funded. The TDI funding has been leveraged, and we've obtained funding from other sources as well as we went, at times in kind, just travel money, at times other stuff. I hope this is, oh goodness, not enough light in here. So what you should see in here is in gray, just contours of continents that you don't see. I leave it to your imagination. And we roughly divide the world into CLT producing regions. And this is because not all companies wish to be singled out by saying this company produces that much and that much. If we aggregate this data by region, they're much easier to share data with us. And that way we have a blanket policy. We never trace the data. We never present the data in any form that can be traced to individual company. And as you can see, we have like Central Europe separated from the other part of the Europe, because Central Europe is like the epicenter. This is where about 80% by volume of CLT is being produced, or projects, if you will, because all CLT is being produced for projects, specific projects. It's a specialty product, not commodity, okay? And while the rest of Europe is developing, just as we are, and finding their way. They are closer to the Central Europe region, so they have some advantage. But there are other regions. So we decided to lump the Japan, Australia, and New Zealand into one Asia-Pacific region. China is launching on Korea, but for this region, we have very little data for now, except that we know that operations exist there. Good development in South America, and one plant in South Africa. What we consider Central Europe, German-speaking sources would refer to as DACH or Alpine region, which is not exactly true because it includes also northern Italy, Czech Republic, and at times, depending on the whim, Baltic states as well. They publish biannually a report that is related specifically to Central Europe, but again with kind of like fluent boundaries, and projection for the new for the next biennium, which is the green bars in here. And as you see, there is existing projection here for 2023, but we are still waiting for the data to confirm that. They predict a big jump. I mean, between 2020 and 2023, they predict that Central Europe is going to add 1 million cubic meters. That would be 1/3 of what we believe is being produced globally right now. Now, this is important because in the same time, this is like over the pandemic period, right? In the same time, we see some hurdles in North America with attrition. 3 companies experience major problems, including our dear Johnson, who just suspended the production. Structurelam, a smart company who got bankrupt and is in process of restructuring. Catera before. I name them because they have been in the news. It's public information. It's not the information I gained from them, right? The predictions tend to be quite accurate. And just for the sake of it, this comparison of this Alpine region to California. So imagine like 80% of global production coming from the area roughly equivalent to the area of California. Things are possible, right? Now, the survey is like a diminishing return for the effort. You can see here, this is our first very successful survey where we engaged over 20 companies across the region. Next survey, the following survey was much lower return for increasing effort. We addressed more companies throughout the region. And now the latest that was aimed at figuring out what was the impact of pandemic was actually the lowest return rate. And this makes us question whether this is a good way of collecting data. In the same time, what I get from the site visits and interviews in the past 2 years, I visited 10 companies, right? Over pandemic, this would be altogether 11 already. And I interviewed another 6. So it's more actually that I got from this survey, right? And I get much richer information. The gossip columns do comment on the coronavirus. This is like one of the very first reactions. You can see it is like pity and kind of quality to the response here. So Corona is not going, not stop CLT. It's double negation in here. But this is actually very much in line with what we are finding. There are very mixed signals. Construction sector has boomed during Corona, and this benefited many of these companies. Expansion of those companies that planned expansion over the, as we now know, a pandemic period, carried on and actually expanded the capacity, not necessarily the production. There were no signs of panic on the sector of mass timber production, but there were also raw material shorts and pricing hikes. Logistics woes, as you know, experienced as much as with any other sectors in economies. Workforce instability, production slows. All of this, depending where you ask, resulted in different impact. There is now, just as much as the industry itself is super diverse, it's still a very young industry. If somebody tells you that this is mature product, mature industry, don't believe that. Everything is still to be decided in the future, right? We are contributing to the development of this very new thing. And the same diversity is being seen in the response to the pandemic and to the alignment to the new normal. So Europe added capacity, North America lost capacity. Whether this was the impact of pandemic is actually not known. So if we look by numbers, this are if we go back, can we go back with this? Okay, so if we go back, these are numbers from 2 years ago. versus new numbers. In terms of the number of plants, there are just slight shift. You can definitely see that the Alpine Europe added number of plants, right? In terms of annual output, you see that the North American output has shrunk some. On the face on it, it does not look dramatic, but this is because one of the companies that produces commodity product, access mats, right? The largest CLT manufacturer in the world, 100,000 cubic meters a year, has qualified the product for structural uses. This on the industry gossip column made shifting this entire volume to the structural CLT column, right? Which does not happen. This company produces hardly any projects with structural CLT, right? So this is misleading. And then per shift capacity, you still see how dominant the Central Europe is, particularly in output. This is the only region that works like 3 shifts consistently, right? While other regions struggle a little bit. And the industry continues to trying surprises and causing baffling puzzles. And this is again the function of this being so new still. Don't believe it is mature. So one of the surprises, the uneven pace of developing. We think that as we have the Central Europe for a model, it should be much easier for us to develop this volume quickly. It is not. It is not, for various reasons. I'm going to touch on it with the other projects that I'm going to overview. The uneven rate of attrition across the region. I mean, attrition does happen. I mean, in all regions, we've seen companies being closed, but none in such pace as we have seen in the last 3 years in North America. What are the reasons? Hard to say. Is coronavirus to blame? Hard to say. The root causes would need to be analyzed, and this is potential projects for TDI. Project number 2 is actually a team, a group of projects utilizing underutilized species, particularly small logs in mass timber pounds, structural mass timber pounds. The general idea would be just to reverse this bed cycle. Again, I leave it to your imagination. It should be like green arrow showing the good cycle below. So instead of letting the small logs burn in dramatic forest fires, we would like to harvest them selectively. And this is a point in here that I'm going to touch on, and use in CLT in modular projects. Perhaps these are not going to be good enough for tall wood buildings, but for small, low-rise modular projects, it should be just fine. We are making quite good progress with this project. Oh, here was the green arrow. And this is I'm going to touch on 2 projects that are just inheriting from the series conducted before, much of this on TDI grants. So one of these recent projects, this one funded by USDA, not TDI, Sina Jahedi found out that the models of elasticity of lumber taken sawn from the small logs, right? Judging by their visual grades, they do not meet NDS specs for Western woods, which is maybe alarming, right? But then you need to understand it's the same wood that we have from regular clearing. The thing is that the NDS values have been developed based on commercial harvesting, where everything goes, and where small logs make a small percentage. Now, if you are doing this selective harvesting, you're targeting small logs. So the predominant volume of what you are testing is lumber sawn from juvenile wood, right? And these do not make the NDS specs. So what are the solutions? You either just forget using them in structural projects, or you may actually and this is one of these objectives of one of sub tasks in this big EDA project. You can try to find out ways of moving this lumber into structural domain. And this would be either by establishing the NDS values for this species asterisk, or changing the grading, visual grading rules, or things are yet to be determined. So this is just, as I'm saying, just one aspect of larger project that involves like 3/4. This is like foresters, right? And I'm the only wood science guy in there breaking stuff rather than growing. This is the budding team. Woody Chang is the PI of this entire 5 million project. And then freshly recruited to, this is our new postdoc, new graduate student. We are still hiring one more graduate student. Why do we fixate on ponderosa pine? Is just poster child of most of the species that are being considered a problem in here. And this is as opposed to, there's nothing wrong with ponderosa pine in general, right? But it's the smallness of the logs and the limited limitations of what you can cut from round logs for lumber. So the idea here is to focus on the stuff that is being removed. So in commercial logging, you would have all of these trees would go. In selective logging, most of the stand would stay, and there would be a small portion that is being logged. They are being assessed on the site, which make any potential for structural uses. Then at the sawmill, we are just switching, this thing, I'm blowing it up for easier perception. They are being graded at the sawmill, at the log yard first, then at the after being sawn. We have an idea that we can confront this with actually advanced technique of visual grading in collaboration with Microtech. And then once this is being done, number 2 and number 3, these are of interest for mass timber panels, would be just tested for properties. And we will see now with also destructive testing, how the values compare to the NDS values, and think of necessary actions after that. We are also thinking that once we are sawing the small logs, it may be economically viable to just sow for thin stock, thin and narrows. Now, these are headache to handle in the manufacturing process. So we were thinking of edge bonding this stock into wider, easier to handle laminations. So this is another area. In the process, we hope to develop a unique database which will connect the first assessment of the quality of the log with the assessment of the quality of the sawmill, then advanced assessment with Microtech scanners, and then actual data taken from empirical testing. This is expected direct impact. I think I'll spare you this thing. Number 3, back to fundamentals. How much time? 3 minutes. Okay. Back to fundamentals. There are like barriers when we think about the rate of attrition for the industry here in North America. I mean, there are a couple of things that come to mind. We have like the strictest product standard, particularly the lamination requirement for the panels, or stricter than anywhere in the world. There are some other things regarding the environmental and business environment in here, but here we are going to attack just the thickness tolerance and related stuff. So when you produce a panel, the important part of this is how you bond the layers together, okay? And there should be no surprises. This is like age-old knowledge, how to make a good bond, right? You need to have plain, fresh surfaces, spread adhesive properly, have a good pressure, have the adhesive cured, right? And once it's all done, you can just test for quality. And in North America, we have like 2 mandatory standards, block shear and the lamination block. Of these 2, the lamination is considered to be a challenge. Whatever could go wrong, right? And yet, if you look at the literature that Sina put together, most of the research reported, and the research is important because it translates to the innovativeness of the market, right? Most of the research has problems with the delamination. Because they don't produce the samples on the production lines, but the prototypes, shop made or a pilot plant and so on. They think that it's difficult to replicate, and it kills lots of promising prototypes, okay? So let's take a look at it. I mean, things happen also in the commercial manufacturing. This is one of the panels that we got from one of our anonymous donors, right? You see thickness tolerance seems to be a problem in here. So one of the problems is how do you sample, right? So you are allowed to sample depending on the size of your panel. If this is prototype, it's very small, you have very little wiggle room. If this is large panel, you have a lot of wiggle room where to source your specimens for the lamination. So if you take and cut entire panel into delamination blocks and do the lamination test exclusively, this is what we find. I mean, delamination everywhere. And yet, this panel would be qualified as passing. And this is because you can eliminate from the delamination samples some that have knots or the edge gaps and so on, right? And then also there's a little bit of gaming in here. But I don't think that the edge bond or knot is necessarily a problem. This is taken from some Q&A lab, right? And you see that the specimen was severely abused, but it's not the knot or the gap that produced the failure in here. We suspect that the thickness tolerance is the thing. And we have a project in books that is going to find out how the load is being transferred from one layer to another. As you have the central block here, different thickness than the 2 on the sides. We are using optical methods to see how the load is being transferred. And you can see that we can essentially figure out, this is like where all 3 blocks are closely matched. This is like flagrantly unmatched, but we can see that this is what makes the central layer not engage at all, not show any strains. So we have a method. This can be used with dry and resonated blocks, 3 and 5 and 7 layers, and we are hoping to develop some fundamental knowledge that should help us. I'm going to cut it at this point. Some fundamental knowledge that should guide next revision of the PRG 320 and our approach of how we approach the Q&A and requirements for the product. I'm going to skip this one because Mariapaola is going to, I'm going to just zip through and get to the place. Let's see. Yes, this place where Mariapaola will have more on this topic. One thing that only that I wanted to say about it is that we did LCA analysis on different scenarios for reusing and reusing the elements from deconstructed CLT projects. And what we found using current LCA models and current LCA database, that nothing beats the landfill. Not even if you deconstruct and rebuild from the intact elements on the same site. It's counterintuitive. We are as shocked as you are, but it speaks something either of the databases used by current LCA, and this is the work we're reported so far. Both Ari, Andre, Erika were speaking about feeling the new data to the LCA models, or with the LCA assumptions, or perhaps with our general thinking or approach to how we construct CLT projects.
No pressure on me. I have a lot, to tell you about what Lech skipped. Well, while we figure out if my PDF will work, yeah, I have, well, first of all, I am a faculty member in wood science and engineering at OSU. I teach and do research on wood design and architecture. I have an architecture and engineering background. And I will talk about integrated approaches for circular economy in mass timber construction. So it will be more like a high-level conversation about how we can incorporate circular economy in our mass timber buildings. And circular economy is at this point a buzzword. I think everybody knows exactly what it is. Apparently, it seems to be a very key topic, a very, very hot topic for the mass timber community, at least the research community. It was a huge topic in the recent World Conference of Timber Engineering in Oslo this last summer. And hopefully I will show something about it. So my research pretty much focused on different aspects of circular economy. And you know that basically it's departing from the current linear model of produce, use, and dispose to a more sustainable model of produce with less, use for a longer period of time, and instead of disposing, re-inputting these resources into the loop. So reusing them in the best scenario, or remanufacturing, repurposing, and at least recycling some of these materials. Yeah, so we talk about these different strategies of circular economy. I learned a new word while I was preparing these slides. Resile, that means being resilient. And so, yeah, the first project, or I would, well, the plot that is there, you cannot even see it. So the first projects, or better series of projects, are really looking at the whole stages of a building life, from production, by reducing or using fewer resources, in this case, underutilized wood species from forest thinning operation, and Lech just talk about it, so I'm not going to repeat it. And then making new, with these new products, building something that can be built with the materials and can have a long life. So we were looking at modular systems and also testing their suitability for seismic regions. But we were also interested in how these modular buildings can be used also in temporary buildings. So this seems to be counterintuitive in this concept of a long service life. But if we do temporary buildings that can be reused, then this makes much more sense. So we prototyped, built and tested a full-scale modular unit here in Portland, and we built it, disassembled, and built it again, and monitored for a long period of time. We rebuilt it in a day, like one working day with 3 workers and no cranes, just very, very basic equipment, and that was very, very interesting. Okay, so the first project, the first wood innovation project that Lech mentioned, was funded 6 years ago, and then it was followed by this other wood innovation grant that looked specifically at ways to utilize ponderosa pine, CLT, in modular buildings. And so like was a co-PI, and Erika also collaborated on this project. We co-advised one of our graduate students, but really it was a big team. And so the students worked synergistically on these two projects, from the material characterization to the then testing, at the different scales, and the scales of the connections that in a modular system are very important, both the intramodular connections and the intermodular connections, so the connections that we use between the modular parts, because we were interested in a system that could be easily deployed, so fast assembly and disassembly. We were interested also in using connection types that allowed this point type of connections provided by rotoblasts. We had to characterize the behavior of these connections in this new material, and also verify the residual damage that could occur after multiple uses, or in case of cyclic loading. So we identify the intermodular screw spacing as a key parameter, for instance, for the reusability of the wall modules, and developed a methodology to design this modular system. Our industry partners, well, in addition to TDI, who supported this project, we had Wagen Timbers, Rotoblas, Andersen Construction, and SMT Research for the monitoring system. Another series of projects look at the two extremes of the building life span, so from production to end of life. And the focus is on using material from the construction projects, or reusing mass timber panels, or even manufacturing waste, so-called remnants or offcuts from mass timber panels manufacturing. And we have two projects also that looked at how we can, what are the criteria to have a successful deconstruction, and what is even the feasibility of deconstructing with mass timber systems, and then new designs for waste materials. So I will quickly go through. The first one, you recognize the ELI project, the 3-story building that has been built and tested in our Emerson lab. And we also did some observations of the deconstruction process, and we were interested in both in acquiring quantitative data regarding the deconstruction process. We are aware that this is a test structure, so not exactly what will be a real building. There are a lot of differences. This was a structure where there were like learning lessons that were learned while doing. So hopefully in a real building, many of these things were sorted out earlier. And then also, I mean, this is just the structural system. We know not finishes, not building envelope in a laboratory environment. Yet we were able to collect a lot of interesting data regarding the construction process in terms of time, tasks, and sequence of activities, and also in terms of reusability, which is a word that needs some reflection. What can we, I mean, what does it mean? Reusability, reusing for the same function in a new building, or repurposing for new functions. Now we know that many parts of this building are going to be reused, but as non-structural parts. So what was the decision? Probably because it was easier, but maybe many of these panels could have been used still as structural elements. So we don't know. This would be an interesting conversation, but there aren't criteria yet to define the reusability. And so this is a very interesting topic that maybe requires some more research, and this is just a sort of preliminary data and observations. And then we have a fun project that has been supported also by the TDI through an ARS fund, small grant, and involves our students. So my colleagues emphasize the importance of next generation of professionals, and we are we involve our students not only in research but also in our educational efforts in our classes. To we engage them in different design tasks and collaborative tasks out this class, in which U of O architecture students and OSU wood science and engineering students work together to develop a design. And in this case, this is the second year that their challenge is to reuse materials, so mass timber remnants, to build reusable structures. So we ended up choosing a type of structure that are reciprocal frames because they're fun, they're intriguing, and also because we were able to use smaller elements also to build potentially larger larger spans, and also investigate use of notched connections and different types of CNC digital fabrication techniques. So yeah, that is fun. And if any of you are interested in reviewing our next iterations of the projects, please come and provide your feedback. Now, during the service life, we do need to care about our building and make sure that it lasts for at least for the designed service life, hopefully for longer. So this is a big part of my research. So we have started with monitoring our own PVL, the first science center complex in Corvallis. We have installed only 350 sensors, not 800 as Andre is planning for the new 6-story building. And it's already a lot because these 350 sensors have been installed already 5 years ago. So Evan was the first put in sensors in the first erected CLT walls. And so we have plenty of data. We have started with analyzing data during construction, moisture behavior, and then we provided early feedback to the construction crew regarding post-tension losses in the post-tension rock and shear walls. And we are still investigating effects of sustained loads, so basically creep and varying climate conditions on these different components, especially the post-tension shear walls. So there are a couple of other projects on creep, and this is so the idea of identifying and evaluating the long-term performance of these components brought then to another project in which we are trying to connect. And unfortunately, you can see part of the slide. It's very bright. But basically, from the building scale to the system scale, we built and tested for 1 year two mass timber post-tension shear walls, one MPP and one CLT in the Emerson lab. And then we also tested at the smaller scale post-tension panels in different environments, constant environments and cycling environments, to characterize both the viscoelastic component and the mechanosoptic, so the component of creep that is also affected by cyclic changes of humidity. We have some preliminary results. We have experimental data, a unique set of data, I would say. I think we did a good job in our experimental design, because we had a 1-year-long COVID year where we couldn't access to the lab, so we could do our work of planning the experiment of shrinkage and swelling and viscoelastic and mechanosoptic creep and post-tension losses. And then we have validated our model to predict creep. And we have also noticed some different behavior between CLT and MPP. For instance, CLT experience more viscoelastic creep, while MPP seems to be more dimensional sensitive to changes in moisture content, but there is still a lot to be to analyze. So these are still preliminary data. Our intention is then to go back to the building and try to understand causes, for instance, of the tension losses that are still occurring in the shear walls. So we want to create a combined model to predict the total panel responses and the resulting losses in the post-tensioning forces, and then validate and combine model with full-scale applications, both of the full-scale walls in the Emerson lab in the building. We have also, so this is a project with one of my grad students in which we are looking at extending the life also in terms of functional life, because in many buildings, not just mass timber buildings, even if the physical durability is, I mean, the building is still in perfect conditions, but it is demolished because it's not functional any longer. So we are looking also at functional longevity and see how we can develop designs that can be adaptable and flexible over time. And we think that mass timber is a great candidate for this. Yeah. So this is a survey that we launched, I think, 1 year ago with one of our grad students who collected your ideas, your perceptions on circular economy and what are the current challenges. And most of, so we had a mix of industry and academia responding, and you identified policies, supply chain, and economic feasibility as the main roadblocks. And also, well, there were some discrepancies between perceptions of academia and industry, but these were kind of consistent. So we are still interested in learning on, about what you think are also our priorities in terms of research. What do you think can be the most important direction for our research? And so I encourage all of you, it's just one question. So it will take you 1 minute at most to respond to this question. Please identify, help us identify critical areas for circular economy informed mass timber buildings. And so there are some few, not all possible strategies, but we are very curious to know what you think. So I'm ending with this, and then I hope there will be more conversation during the break.